All right, so let's look at number 1. We are solving using a common base. You don't need your calculator for the common base questions. We need to figure out 81 is 3 to what exponent? So 3 to what exponent would give us 81? 3 to the 4th exponent. Perfect. So I can change out that 81 to be 3 to the 4th exponent. The left side stays the same. Once our bases are the same, what can I do? Cancel them out. So I have negative 3x minus 3 is equal to 4. What should I do next? Add 3 to both sides. So negative 3x is equal to 7. And then what's the last step? Perfect. So x is equal to 7 over negative 3. All right, number 2. So I want to change 16 to be 4 to some exponent. 4 to what exponent would give me 16? 4 to the 2nd power. So I have 4 to the power of 3n is equal to 4 squared. Once my bases are the same, what can I do? Cross them out. So 3n is equal to 2. And then what's the last step? Divide by 3. So what does n equal? 2 over 3. Perfect. All right, number 3. So I want to make 25 be 5 to some exponent. 5 to the 2nd power. Oops. So 5 to the power of negative 2x minus 1 is equal to 5 squared. Once my bases are the same, what can I do? Cross them out. So I have negative 2x minus 1 is equal to 2. Then what can I do? Add 1. So negative 2x is equal to 3. And then what? Divide by negative 2. So x is equal to negative 3 over 2. All right, number 4. For 4, my bases are already the same, so what can I do? Cross them out. So I have negative 2k is equal to 3 minus k. Now here I have a k on both sides, so what should I do next? Add k. So I want to combine my like terms, so I got to move it to the other side. So what's negative 2k plus k? Negative k. So negative k is equal to 3. And then how would I get k all by itself? Divide by negative 1. So what does k equal? Negative 3. So next we're going to be solving where we can't get a common base. We have different bases here. So we have to use a calculator. So when you have different bases, the first step is to put it into log form. So remember, log form, we start with our word log. What's our base here? 9. And then switch these two. So what would come next?
72.
And what's it equal to? 9m. And then we can put this into our calculator. So it'd be log base 9 of 72. So we have to use the change of base. So that would be log of 72 divided by log of 9. My calculator needs light to work, so it's too dark. All right, so log. So when we put this in our calculator, what do we get? 1.94639. And then we're going to keep that number in our calculator because we just have one step left to do. What's the last step? Divide by 9. So keep that number in your calculator. You just put divide by 9, and then that's your answer. So m is equal to 0.216. Awesome. So I want to put this into log form first. So I start with log. What's my base? 6. What would come next? 4. And then what's it equal to? B plus 5. What should I do next? Right, so I need to do the change of base. So I have log of 4 divided by log of 6. And I put that into my calculator. So when we put this in the calculator, we should get 0.7737. And then what's the last step? Have to move the 5 over, so I would subtract 5. So I keep that number in my calculator and just put minus 5. So we would get negative 4.226. So I put it into log form. So I start with the log. What's my base? What's the base? 16. And then what would come next? 9. And what's it equal to? 4b. So now I have to do log of 9 divided by log of 16 in the calculator. Perfect. 0.79248. We're going to just keep that in our calculator so it doesn't matter how many decimal places we write down. And then what's the last step? Divide by 4. Awesome. 0.198. So here we are solving. When we have logs on both sides of the equation, we want it to be just 1 log equals 1 log. So how can I combine the left side to just be 1 log here? When I condense it to a single log, if I'm adding, what goes with addition? Multiplication. So I start with 1 log, and what am I multiplying? 5 times 3x. So what would 5 times 3x be? 15x. And then it's equal to log of 23. So if I have a log on the left side and a log on the right side, what can I do? I just cross them out. And then I set 15x equal to 23. And then what would be my last step here to solve? Divide. Divide both sides by 15. So x is equal to 23 divided by 15. It says round our answer to, I think, the 10,000. So I think that's 4 decimal places. On the test, it'll say like round to 3 decimal places. You can't just leave it as a fraction? No, because it says to round, so it doesn't want a fraction, it wants a decimal. So 23 divided by 15.
So all we do is just divide it by 23.
Yep. So it'd be 1.5333. All right, let's do number 10. So again, I have 2 logs on the left side. So what do I need to do to combine it to be 1 log? What goes with addition? I multiply them. Perfect. So I have log. What would I multiply here? So it's 5 times 4x. 20x. Awesome. So I have log of 20x is equal to log of 9. If my logs are the same, what can I do? Just cancel them out. So 20x is equal to 9. And then what can I do to solve for x? Divide by 20. So x is equal to, and we just put 9 divided by 20 in our calculator. And that gives us 0.45. All right, let's take a look at 11. So I always want it to be just 1 log on one side. So how would I combine these 2 logs together? Division. If we have subtraction, we combine them by dividing. So I have log, and what would I divide? So 2x divided by 4. When you condense it, you're getting rid of the other log, so it's just one log there. And then it's equal to 2. So here I only have one log in my equation. What would that base of the log be?
2 logs.
The base of the log. 10. When it's not written, it's implied that that base is a 10. So if I put this into exponential form, I start off with my base, which is 10. What would come next? 2. And then what's it equal to? 2x over 4. So now from here I solve. So what's 10 squared? 100. And then that's equal to 2x over 4. To get rid of that 4, since I'm dividing the x by 4, what can I do? Multiply the 4 on both sides. This would be 400 is equal to 2x. And then what's the last step? Divide by 2. So what's 400 divided by 2? 200. So we rewrote it into exponential form here. Yes. It'll cancel. All right, number 12. So first step is to combine them. How do I combine the two logs if I'm adding? Multiplication. So I have the log, and what am I multiplying? You can. So I'm multiplying the x plus 10 and the 5. So it'd be like 5 times x plus 10. And then we can distribute to simplify it inside of our log. So it'd be log of 5x plus 50. So you don't have to distribute, but you can. Yeah, it's a little bit easier. So next I want to put it into exponential form. So what's the base on my log here? 10. Remember, it's not written, it's 10. So we start with the 10. What's my exponent? 1. And then what's it equal to? 5x plus 50. And then I can solve. So what's 10 to the first power? Just 10. What would I do next? Subtract 50. Oops. So what's 10 minus 50? Negative 40. And then what's the last step? Divide by 5. So what's negative 40 divided by 5? Negative 8. Awesome.